is my third video, and basically explaining how the FSM and the counter components come together to implement our vending machine. So here we have our top module. We're going to need a clock, a reset, a nickel, and a dime. That's going to be pretty much standard because both our FSM and our counter needs these things to get their correct outputs. And then in total, we're going to have an items remaining and remaining items and purchased items, as well as the amount total. And we are not using the FSM's direct output to get our number of purchased items, and that's just basically the whole point of the concatenation of the FSM and the counter components. So we'll see that down here. Here is our architecture, and we're creating and declaring a FSM component. We have our clock, our reset, our nickel, and our dime, and then our original FSM was the vend output. And you can see here, we go to our FSM, and we had a vend. We didn't have an item purchased, and that just basically is different because we're not trying to take into account how many in the FSM. We're just trying to take into account that something has been purchased, and so then we also declare our counter account component, and it has a clock, a reset, a purchased, and a nickel and a dime. And this purchase is going to be used from our vend output from the FSM as an input into the counter, which is going to allow us to know that an item has been purchased. So we create a signal that goes in between the FSM and the counter, from the vend from the FSM to the purchase of the counter, and we can see that here. So in our FSM instance that we instantiate, we connect all of our signals, and then vend goes to our signal vended, and in our counter instance, purchased is taken from vended, which was our signal. And so then once we look at our wave format, you're going to see how when the reset is on, all of our outputs are reset to their original states. So purchased items is reset to 0 because we have 0 purchased items. Remaining items is set to 15 because that means we have the total, the maximum amount of items remaining, and then the amount is 0. And notice that there are 5 bits for the amount because the most that we are expecting in a cycle is 20. So after a reset into the next positive clock edge, we see that you receive a nickel, and items purchased and remaining items stay the same because we don't have enough money. And then the amount goes to 5 in binary, so we can see that here. Then when we go to the next positive clock edge, we have nickels, another nickel, which means that we should have 10 cents as a total amount, which we do in our total. Items remaining and items purchased are still the same because nothing has been bought yet. We see that on our next positive clock edge, we receive a dime, however, and that we know that we're going to have 20 cents now, which we can see it's here in binary. And then the items remaining, we decrease it decreases by 1, and then the items purchased increases by 1 as well. And so on our next positive clock edge, we see that our purchased items does not change, and neither does our remaining items. We receive 5 cents, which means that we should have 25, that's here, 25 cents in our total amount. When we go to our next positive clock, we still have another dime. So we get 30 right here. And we still haven't purchased anything because we would need 15 cents more. Once we go to the next positive clock edge, we see that we have a dime, and we have 40 cents now. So in binary, we are missing the extra 1, but it truncates, so our amount, this just shows our the correct amount, 40 in binary with the truncated 6-bit. And we also see that we lose an item remaining, and then we gain an item remaining. And that just shows the functionality of our vending machine. This continues throughout the entire process. So, thank you.